Hey everyone, this is Bhargava and today we are going to start with a new chapter, counting. Now, in this today's session, we will discuss the following topics. The first one is pigeonhole principle, and the second one, that is permutation. Now, first, what is counting? As the name suggests, it is counting of anything. It can be counting of numbers or it can be counting of objects. Now, first, what is a pigeonhole principle that we will discuss? Okay. Now consider this image. Okay, here we have 9 pigeonholes and 10 pigeons. So what will be the best case scenario? That means if we put all the pigeons in one pigeonhole, then there obviously at least one pigeonhole is there in which there will be two pigeons. So this is the best case scenario. There can be other cases like all the pigeons are occupied in one pigeonhole. There can be many cases. Okay, so what does it say? If there are many pigeons and a few pigeonholes like this, we have 10 pigeons and holes are 9. That means less than this. So if there are many pigeons and a few pigeonholes, then there must be some pigeonholes occupied by two or more pigeons. So this is the best case scenario. Now, what is extended pigeonhole principle? In general, if the number of pigeons is much larger than the number of pigeonholes, then the pigeonhole principle can be extended as like this. If n pigeons are assigned to m pigeonholes, then one of the pigeonholes must be occupied by at least this bracket indicates the integer part, at least n minus 1 by m plus 1. Again, I am repeating, if n pigeons are assigned to m pigeonholes, then one of the pigeonholes must be occupied by at least n minus 1 by m plus 1. Here it is the word at least, so it does not give the exact count. It will give only the at least part. So just consider this. Let us consider one or two examples based on this. First, if 7 colors are used to paint 50 bicycles, then at least how many bicycles will be of same color? If 7 colors are used to paint 50 bicycles, then at least how many bicycles will be of same color? So here, what is n and what is m? So here, n, that is 50. So whenever the number is more, then it must be pigeons. Okay, so n equals 50. That means the number of pigeons are 50. So number of pigeons are more than the pigeonholes. And m equals to 7. That means 7 colors are there. So by extended pigeonhole principle, at least how many bicycles will be of same color? It is by this formula, that is integer part of n minus 1 by m plus 1. Here n is 50, so 50 minus 1 divided by 7. So 49 by 7 plus 1. So 7 plus 1, that is 8. So hence there will be at least 8 bicycles that will be of same color. Easy. Now next, among 100 people, at least how many of them were born in the same month? Okay, so here 100 people are there and in the same month. So here the pigeonholes are 12 and the pigeons are 100. How 12? Because we know that there are 12 months in a year. So n equals to 100 and m, that is 12. So by extended pigeonhole principle, at least there will be integer part of n minus 1 by m plus 1 people who were born in the same month. So if you calculate this, so it will be 100 minus 1 divided by 12 plus 1 equals 2. It will be 9 because it is an integer part. So 9 were born in the same month. Now, what is permutation? There are two types, permutation and combination. In this session, we will discuss permutation, and in next session, we will discuss combination. Now, any arrangement of a set of n objects in a given order is called permutation and taken all at a time. Again, any arrangement of set of n objects in a given order is called permutation. Any arrangement of any r less than or equals to n of these objects in given orders called R permutation or a permutation of the n taken r at a time. For example, consider a set of letters A, B, C and D. Then, first, here BDCA, DCBA and ACBD are permutations of four letters and taken all at a time. Okay, so there can be another permutations, but these are three examples. Like ABCD is also there. Next, BAD, ACB and DCB are permutations of the four letters and taken three at a time. Next, AD, BC and CA are permutations of the four letters taken two at a time. Now, what is the theorem? The number of permutations of n objects taken R at a time R. This is the formula theorem, and it is denoted by like this: NPR or P bracket NR. That means permutation of n objects having or taken R at a time, and it is n minus 1, n minus 2 up to n minus R plus 1. That is n factorial upon n minus R factorial. So we just simply remember this: NPR equals to n factorial upon n minus R factorial. That means permutations of n objects taken R at a time. Okay, so permutation means arranging. This is very important. We will use it in each and every example. Now, permutation with the repetition. So whenever something are repeating, then what will be the permutation? Now, the number of permutations of n objects taken R at a time, provided M1, M2 up to Mn are repeating. Okay, then what will be the permutation? NPR, again it is the same symbol, that is P and R. Now, the change is here: NPR upon M factorial, M2 factorial up to Mn factorial, and that is n factorial upon n minus R factorial. So we will just remember this. This is the simplification one, but we will remember this. So n factorial upon n minus R factorial, and whatever the numbers are repeating, whatever it is repeating, so we'll just divide it by its factorial. That is m factorial, m2 factorial, mn factorial. This is also important. Now just let's take examples based on this. First, how many 5 digits numbers can be formed if repetitions are not permitted? So here repetition is not allowed. Okay. Now we want to construct 5-digit numbers, and we know that, okay, how many digits are there? So we know that 0 unique. How many unique digits are there? So 0 to 9. So there are total 10 digits, and out of which we can construct 5-digit numbers. Okay, so out of 5 digits, the first digit, now we will select it one by one. Now for the first digit, now 0 cannot be used, because if we put 0 in first place, so it will be a 4-digit number, so that is not possible. So we have total 10 digits, that means 0 to 9, that means 1 to 9 and 0. So out of 5 digits, the first digit can be of 9 digits, as 0 cannot be the first digit. Now second, now we have how many possibilities for first digit? That means 9. Now for second digit, 0 can be put. Okay, but we have but here repetitions are not allowed, so we have chosen already one digit for the first digit. Okay, so second digit can be any of the 9 remaining. How? because for first digit there were 9 possibilities. For second digit there will be 10 possibility, but we have already chosen one for the first digit, so there will be 9 possibility. So 9 including 0. Now for third digit, again we will just decrease one digit. So for third digit, it can be of any of the remaining 8 digits. For fourth digit, it can be any of the remaining 8 digits. Next, and fifth digit, it can be any of the 8 remaining digits. So what will be the final answer? Hence, the total number of 5-digit numbers can be formed in 9 into 9 into 8 into 7 into 6 ways. Again, see, there are 5 digits. Okay, now first one, total we have 10 digits. Now 0 cannot be placed in first place, so there will be 9 possibility. So 9 is fixed. Okay, now for second digit, here, so again there will be 10 possibilities, but here repetitions are not allowed and 0 is included. So total 10 digits are there and we have already fixed here, so there will be 9 digits. Now again, total 10 digits are there. We have already choose 2, so remaining are 8. So 8 now into 7 into 6. So these many ways are there to construct a 5-digit number whenever repetitions are not allowed. Next example, how many 4-digit numbers can be formed out of digits 1, 2, 3, 4, 5, 7, 8, 9 if the first one, repetitions are not allowed, and the second one, how many of these will be greater than 3000? Okay, let's discuss. We know that what will be the first answer? So it is like the previous one. So here total how many digits are there? 8. 8 digits are there. Okay. 3 and 3. Okay. 8 digits are there. Now no repetitions is permitted. Here there is no 0. For first digit we have total 8 possibilities. For second digit we have 7 possibilities. Then 6 and 5. So 8 into 7 into 6 into 5. So in 1680 ways we can create a 4-digit number using this 8 digits. So this one is easy. Now in second, how many of these will be greater than 3000? And this is all, and here also repetition is not allowed. Just consider that. Now it will be greater than 3000. So here we have 4-digit number. So these are the places. This is unit place, tenth place, 100th place, and 1000th place. Now we have given the condition that it has to be greater than 3000. So that means for 1000th place we cannot choose the 1 because it is greater than 3000. We cannot choose 2. We can choose 3, 4, 5, 7, 8, 9. So for 1000th place, how many possibilities are left? So we have total 8 digits, and 2 are not included. So that means the 1000th place or first digit can be chosen in 6 ways. So here the number must be greater than 3000. So the first digit can be filled out of the numbers 4, 5, 7, 8, 9. So that is 6 different ways. Now for 100, we have out of 8, we have fixed the first digit. Okay, so we have used one number. Now for 100 base, there is no restriction. So there are total 8 numbers. So for out of 8, we can fill this number by in 7 ways. Okay. Now again, now third digit can be filled out of 8 remaining digits, and last it will be of 5 remaining digits. So here only this restriction for 1000 place there is difference. Otherwise it is very easy. Again, it is greater than 3000. That means 1 and 2 cannot be there. So here there will be 6 ways. Now total there are 8 digits. 1 is already used. So there will be 7 possibilities. So here 6 possibilities and 5 possibilities. So the total possibilities will be 6 into 7 into 6 into 5, that is 1260. Now Find the number of permutations obtained by arranging all letters of the word combination. Calculate how many letters are there. So I think there are 11 letters. So here there are 11 letters. So we know that the total permutation is 11 factorial. But you can check that some letters are repeating, like this O, then I, and N. Yeah, I think yes, there are only three. O is repeating, I is repeating, and N is repeating. But the letters O, I, N are repeated how many times? Two times. So what will be the permutation? So hence the total permutation are 11 factorial. Now O is repeating two times, so 2 factorial. I is repeating two times, so I factorial. And N is repeating two times, so 2 factorial. Now suppose here N repeats three times, so here instead of 2 there will be 3. Okay, so easy. Thank you.